You know, we see these amazing feats of engineering all around us every single day. The bridges we drive over, the smartphones we can't live without. But behind every single one of those creations is a chain of decisions. And sometimes just one of those decisions can be the difference between a total triumph and an absolute tragedy. Because engineering at its core isn't just about what we can build, it's about what we should build. And that one little word, well, it changes everything. See, the power to create is also, in a way, the power to destroy. That's the fundamental tension right at the heart of engineering. And it's exactly why ethics can't just be some afterthought. To really understand the stakes, we need to look back at one of the most sobering moments in modern history, the tragedy of the Space Shuttle Challenger. This is a really haunting quote. It comes from the brilliant physicist Richard Feynman, who was part of the commission that investigated the 1986 disaster. What he's saying here is crystal clear. This wasn't some random act of nature or a simple mechanical fluke. No. It was a human failure. A series of terrible decisions that ignored clear warnings and led to a catastrophe that was entirely preventable. Okay, so here are the cold, hard facts. It was a freezing morning in Florida, way colder than any previous launch. The engineers knew. They knew that the shuttle's critical rubber O-rings could fail in that kind of cold. This wasn't a wild guess. They had the data. They raised the alarm, basically pleading for a delay to protect the lives of the astronauts. But their ethical duty to protect human life was overruled by management pressure to launch. And 73 seconds later, 7 astronauts paid the price. And this, right here, is the absolute heart of the issue. Technically, legally, the launch was compliant. No laws were actually broken. But was it right? Of course not. It was a catastrophic failure of judgment. This is where we see the real limits of the law. Laws tell us the bare minimum we can get away with. But ethics? Ethics ask us to do what we should do. They demand a much higher standard of care, especially when human lives are on the line. So, if the law isn't always enough to guide us, what tools do engineers actually have to navigate these incredibly complex dilemmas? Well, this is where we find their moral compass, the solid foundations of professional ethics. So, where does an engineer turn? First, we have to get this key distinction. We all have our own personal ethics, right? Our sense of right and wrong, shaped by how we were raised and our own experiences. But in a field like engineering, there's something else, a shared set of professional ethics. This isn't just about what you believe personally. It's a formal, universal standard of conduct. It's what ensures that every single engineer, say on that Challenger launch team, was bound by the exact same primary duty to public safety, creating what should have been an unbreakable line of defense. And right at the core of that professional standard is one single word: integrity. And it's so much more than just being honest. It's having the courage to stand up and say, the data shows a design is unsafe, even if it's going to cost a lot of money. It's refusing to cut corners just to hit a deadline. Integrity is the bedrock that ensures an engineer's first loyalty is to the truth and to public safety, not just to their boss or their company. Now, this idea of integrity isn't just an abstract concept. It's written down, formalized, in codes of ethics just like this one. You should think of this not as a boring set of rules, but as a set of promises. And look at that first promise. It's always the same. Uphold public safety, health, and welfare above all else. You could call this the Challenger Rule. It's the framework that is supposed to empower an engineer to say no when something is unsafe, giving them the full backing of their entire profession. All the other points here really just support that one primary, sacred duty. Okay, so the number one duty is to prevent physical harm. We've got that. But what about other kinds of harm? In the world we live in today, technology can cause social harm too. The ethical circle has gotten bigger. It's not just about keeping people physically safe anymore, but also about making sure the technologies we build are fair and just, and don't end up hurting entire groups of people. This is such a critical idea to wrap your head around. Technology is never neutral. Why? Because it's made by us, by humans, and it can inherit our flaws and our biases. An algorithm or a product design can accidentally become a vehicle for prejudice, reflecting and sometimes even making societal inequalities worse, especially when it comes to gender. And this isn't just some theory. When a design team, maybe without even realizing it, assumes their user is male, the final product shows it.
For decades, car crash test dummies were based on the average male body, which led to cars that were literally less safe for women. Early voice recognition software really struggled to understand higher-pitched voices. Even today, some AI systems are less accurate at identifying the faces of women and people of color. The lesson is simple, but it's profound. If you put biased ideas in, you're gonna get biased and sometimes even dangerous products out.
So how do we fix this? Well, the best antidote to biased design is a real commitment to gender justice. And this isn't about treating everyone the exact same. It's about equity, recognizing that different people have different needs and challenges. It's about building diverse teams so we have more perspectives and can cover our blind spots. And it's about actively seeking justice, not just trying to avoid harm, but working to fix the biased systems of the past.
So that circle of ethical duty expands, from keeping individuals safe to treating all of humanity with fairness. But there's one last huge expansion of that circle of care. The responsibility now extends beyond people to the planet itself. The modern engineer isn't just a builder for our society, but a steward of our one and only shared home.
A really useful way to think about this is something called the triple bottom line. The idea is that a project is only truly successful if it wins on 3 fronts at once. It has to be good for the planet, good for people, and yes, it still has to make economic sense. If you sacrifice any one of those pillars, like, say, a green project that exploits its workers, then it's not actually sustainable at all. It's just not.
And to get there, engineers have to fundamentally redesign our whole economy. For centuries, we've lived in this linear world. You take resources from the earth, you make something, and then you throw it away. Take, make, waste. Engineers are now at the very forefront of creating a circular economy. They're designing products that are meant to be repaired, not just replaced, to be taken apart and reused, not just tossed in a landfill. It's a massive shift from a system based on waste to one based on renewal.
So, as we pull all these threads together, public safety, social justice, environmental stewardship, what we start to see is a new, much more complete vision for what it means to be a modern engineer.
And really, it all comes down to this one simple, incredibly powerful idea. For 100 years, the question that drove engineering was, can we do it? But the ethical engineer of today asks a much harder and way more important question, should we do it? That is a huge shift, moving from just celebrating what's technically possible to taking full responsibility for what is humanly necessary.
And this brings the responsibility to all of us. Engineering is actively shaping our collective future, and the challenges we face are just immense, from climate change to social inequality. So I'll leave you with this to think about. Knowing the huge power and the deep ethical duty of engineering, if you could set them on a single task, one problem to solve for all of humanity, what would it be?